Hello everyone, welcome back to the channel. So today's problem is 868. Before starting the problem, let's see the quote of the day. Don't watch the clock, do what it does and keep going. It clearly means that just keep doing your efforts and don't worry about the time you're spending. Everybody takes their own time. Just keep doing the hard work that you are doing. Let's start the problem today. So today's problem is easy marked. Let's see how we can read the problem. So we are given a positive integer n, okay, and we have to find the longest distance between any two adjacent ones. Okay, got it, in the binary representation of n. Okay, so while reading, so what do we understand? So we are given an n, we have to convert it into binary. Okay, and then for find adjacent set bits. Okay, got it. So if there are no two ones, return 0. No two adjacent ones, return 0 if all zeros are there. Suppose if n is 0, that is fine. Two ones are adjacent if there are only zeros separating them, possibly no zeros also. Okay, so we are talking about a scenario where 1 0 0 1 1. So the answer for, let's take a different color, the answer for these two is what? Okay, that should be 3, and the answer for these two would be 1. So how am I doing? So it's 0 1 2 3 4. Okay, so I'm clearly subtracting the positions. So 3 minus 0 is equals to 3, and over here 4 minus 3 is equals to 1. Got it? So this is how we have to calculate the position difference of any two adjacent ones. We are not considering zeros, so if even if there are zeros in between, we have to consider them as adjacent. Okay, that's great. Now let's see an example. So we are given over here a 22, which is binary representation 1 0 1 1 0, and if we see, let's mark their positions first. Okay, 0 1 2 3 4. Amazing. Now let's see what is the difference between these two. How many do you see ones? Okay, these are the two pair of ones. Again, I think it's the same example. uh, so 2 minus 0, that becomes 2 minus 0 is equals to 2, and over here 3 minus 2 equals to 1. So our maximum is what? So we just don't have to find out the differences, we have to find out the maximum, and among 2 and 1, 2 is the maximum, and we return 2. Amazing. Now I can think of two approaches over here. So one is, so suppose 1 0 1 1 0, let's take the same example, and that is 22. Now if I can go over here, I can just convert it to binary, and I can loop over here from starting from left side, because the first number or the first digit will always be 1. Am I correct? First digit will always be 1. Okay, that's amazing. So this will be 1. We have got our first position, we can mark it as previous. So we'll take current, we'll take previous, and what else do we have to take? We have to take answer, that is the maximum difference. I think that's it. So these are the three things we need to take. Okay, if I just keep it over here. Okay, now let's see. So for over here, What, let's remove this. Yes, so over here if we see the current, what is our current is, this is the first, so current is 1. Then so current is 0. Actually we are talking about positions, this is position. Previous is -1, answer is currently 0. Okay, so we have got our 1 now. So let's see, we jump to next, and our current is 1, our previous becomes 1, our previous becomes 0 because this is a significant bit. Now we have taken this position, and our answer is still 0. Awesome. Now we jump to next one, and over here we see that we have again got a significant bit. Our current position is 2, and we see, okay, this is 1 now. So what do we say? 0 1 2, we subtracted by the previous is 0, so our answer becomes 2, and our previous is 0, so 2 minus 0, it becomes 2. Great. Then we again found 1, so this is position 3. Our previous significant set bit is 2, and our difference becomes 1. We have got over here, our current is 4, our last is 3, and our answer is 2. Over here, this is something I marked wrong, because we have to take the maximum of the answer, and it is 2, so this won't be the answer. Got it. So I hope you understood the solution. Now there are two approaches that I can think of. One is we can traverse from right to left, and second is we can go from left to right. This will be our for loop, in which we have converted the binary as string, and then we are looping it, and over here we are actually gonna do the bitwise operations, which is right shift. Okay, so let's see how it looks in code. So I am gonna do the right shift part. So we are gonna initialize current, we are gonna initialize previous, we are gonna initialize our answer. These are the three things that we just dry run. Then we are gonna start our while loop, and we are gonna run till our integer that has been given is greater than 0. And then it's very important to note this down: if n and 1 is greater than 0. Now I hope you know this answer. What will this return? Are you getting confused over here? Let's see over in the explanation section. Okay, so this is our AND operation that we just did. Now how does it help? What is the AND operation that we are doing? This is a logical operation. Everyone should know about this. This is asked in interview a lot. So 0 0 0 1 0 1, this is the bitwise operation that we are trying to do, and we are trying to do AND operation. Now so over here, if 0 and 0 are there, we mark it as 0 0 1 0 1 0 0 and just 1. So if both are 1, then only we are gonna go for 1. Now if we know this, we know that n, for take an example of 1 0 1 1 0 and 1, it can be also written as 0 0 0 0 1. Now if we do the AND operation of them, what will we get? We will be just getting zeros. Am I correct? And why so? Because our first operation, like our first bit or the least significant bit, is actually 0. So when we are trying to do an AND operation, we are getting zeros because this is the only bit that we are actually caring about right now. So if once this is 0, then we just do the right shift. If if all zeros, do right shift. Great, awesome. Now if we do the right shift, and what do we get? So we get 0 1 0 1 1. This is what we get after right shift. But still we'll do what? We'll do AND operation with 0 0 0 0 1. Now in this example, what will we get? Our output would be 0 0 0 0 1. Am I correct? Now if we say that it is actually greater than 1, so what happens now? It's like we have got to know that the least significant bit is actually a set bit. Now if this is a set bit, we can note down the position of this and store it in our current position, check for the previous bits like this, and we can calculate the difference. Have you got the point? I hope you have got it. So let's jump back to the code. Okay, so now we are gonna initialize, so we are gonna check our answer. Now there's one more thing. If our previous is 0 or if our previous is -1, what should be our case? So in case of a previous is -1, we are just gonna return answer. Otherwise we are gonna return answer, maximum of answer versus current minus previous. Great. So we have got this. Now what we are gonna do is we are also gonna initialize our previous as current, and then we are gonna increment our current position. Then we are gonna do right shift. Now right shift part, I hope you know this. Right shift is nothing but n equals to 1. This is nothing but division of 2. So I'll just explain it with an example. So over here, if I see, we are talking about n right shift 1, which is equals to sorry, this we got it m. Okay, n equals to n again m. What is happening? Okay, yes. Now if I take an example of n equals to 12, then in that scenario, what is our binary of this? 1 1 0 0. Am I correct? So if I do the right shift, what will happen? It will become 0 1 1 0 after right shift. And what is the value of this? This is actually 6. So if you will notice it correctly, n this is actually division by 2. So it continuously divides it by 2, which is actually right shifting the binary. So now if we have got this, our answer is almost complete. We have to return answer, and let's see if this works with all our test cases. Awesome. Let's try and submit this. Superb. So we have got the answer right. I hope you understood the approach that we have tried to do, and see you in the next video. Thank you.